Hello, hi all. Sorry for the delay. There was some technical errors that was happening, and that's the reason why I got late to begin the webinar. All right. Anyways, I hope everyone has joined in. Kickstart the webinar. Okay, let me begin by introducing myself. I'm Subin Muhammad Salim from Dynatech Innovations, and in today's webinar, we'll be focusing on the basics and a complete overview of our drone-based GPR solution and how in the recent times the integration of this technology has proven to be efficient and helpful in search and rescue of landslide-stricken areas. Okay, then let's begin. Let's begin by the basics of GPR. I hope you all are aware of what a GPR or ground penetrating radar is. But then again, for some who would like to know the basics, I'll kickstart with that. Ground penetrating radar is a technology, is a non-invasive technology that is used to image and detect the subsurface of the earth without digging or disturbing what lies on the surface. So in effect, no surface is disturbed, nothing is digged up, and we will be getting the image or the idea of objects that lies under beneath the surface. And basically, that is what a GPR is, and it can be used to detect or get images of objects under the earth, such as concrete, metals, pipes, cables, or even in cases of landmines as well. Now, to the basic working principle of GPR. Okay, GPR has mainly two units, actually two systems, one a receiver system and one a transmitter system. The transmitter of the radar transmits electromagnetic waves in the form of radar signals. These radar signals transmitted by the GPR goes into the ground, and its various properties such as altitude, frequency, speed varies on different objects. So when these signals hit and gets reflected back from any different surfaces, the reflected signals will be having a different physical properties. These reflected signals are then collected by the receiver and analyzed to understand what are the anomalies beneath the surface. That is the simple explanation of how a GPR works. I hope I am clear, and in case I miss out on something or you are not clear of what I have been saying, please do feel free to comment that on the chat section. Yes. So basically, radars send electromagnetic waves into the ground. It gets reflected back from objects underneath the surface, such as rocks, pipes, or whatever is lying beneath. And these signals are then analyzed by the radar system to understand what it is and where the location of these anomalies are. Now, to the basic structure of the drone-based GPS solutions that we offer. The hardware component include mainly the GPS sensor. GPS sensors can be of different types and different models depending upon the requirements, how deep it wants to go, how the size of the object it requires to detect. Depending on all these factors, the GPS sensor model varies. Next is the SkyHub onboard computer. The SkyHub onboard computer is the heart of the solution. It is the part that integrates all the other items to the drone's system. Next, we have an altimeter, which can be a radar altimeter or a laser altimeter for true terrain following. Then a radar obstacle avoidance sensor to sense something in the way of the drone and detect from the path to avoid colliding with the object. And so these are the basic parts of the solution, airborne GPS solutions that we offer. Now coming to the drones which are compatible with our solution. Basically, the solution is compatible with most of the DJI and non-DJI drones. Though we recommend DJI Matrix 350 RTK, there are other drones as well which can be integrated with our solution. But the only criteria being that your drone must be equipped with an autopilot system such as Pixhawk or Autopilot and must have a minimum payload capacity to lift up the equipment itself. Usually the equipment is around 2 to 2.5 kg, so anything above payload capacity that would be good for the use. And as I had mentioned earlier, there are different types of GPS sensors depending upon your requirement. There are different kinds of GPS systems, and these sensors can be broadly classified into two categories. One, the low frequency GPS system, and next, the high frequency GPS system. The low frequency GPS system, as the name suggests, emits low frequency radar signals. These low frequency signals can penetrate deep into the surface. So the penetration depth of such sensors will be very large compared to that of high frequency GPS system. But the catch being that the size of the objects that can be detectable by this GPS sensors will be slightly bigger than that can be detected by high frequency GPS systems. So low frequency GPS systems are perfect for projects that require deep subsurface scans. High frequency GPS systems, on the other hand, produces radar signals of larger frequencies, which can detect small, which can detect small objects compared to that of low frequency GPS. But the penetration depth that these signal travels are limited. As the frequency increases, the penetration depth decreases. Those are inversely proportional, to say in short. So, low frequency GPS sensors travel longer distance below the surface of the Earth, but on the same hand, the size of the object will also be larger that it detects. High frequency signals travel shorter distance beneath the ground, but it can detect even smaller objects. That's the main difference between these two categories, the low frequency GPS system and the high frequency GPS system. So the models of GPS sensors based on these classifications are Sound Aero 1000, Sound Aero 500, and Sound Aero low frequency LF. So these are the three basic models of GPS systems that we provide. The Sound Aero 1000, as the name suggests, has a frequency of 1000 megahertz. Sound Aero 500 also has a frequency of 500 megahertz. These two, the Sound Aero 1000 and the Sound Aero 500, are high frequency GPS systems. So they are most appropriate for situations where you need to detect smaller objects at a lower depth. The zoned arrow LF is a low frequency GPR radar sensor, and these can be used for larger depth of scans. And in default, the zoned arrow LF come with three dipoles, which emits 100 megahertz, 150 megahertz, and 300 megahertz respectively, the frequency signals. And also, other low frequencies dipoles can be ordered upon your request. I hope this is clear about the models, the GPS sensor models. The sound air of 1000, sound air of 500, which are the high frequency sensor, and the low frequency sensor, sound air of LF, which comes with three low frequency dipoles: 100 megahertz, 150 megahertz, and 300 megahertz. Okay, now we will go into deeper look at the properties of these signals or radar systems. So first, the 1000 megahertz frequency signals. These are the basic properties of such sensor. It can travel up to a maximum of 1 meter, but 0.5 meter is what usually from the drone it detects. And the size it can detect will be up to 7 centimeters. The Sound Aero 500, it will be having a much larger depth than Sound Aero 1000. And as I said earlier, when the depth increases, the detectable size also increases. So the minimum size of object that 500 aero can detect will be around 10 centimeter at a depth of 2 meters or 1 meter at the max. Then comes the three low frequency dipoles of the Sound Aero LF model. The Sound Aero LF model has three dipoles, the 300, 150, and 100. And all those has larger depth, larger penetration depth. And the size of the minimum size of the detectable objects by these sensors are also larger. As you can see over here, Sound Aero 300 dipole has a detectable minimum size of 20 centimeter, 150 has 35 centimeter, 100 has 50 centimeters. But on the other hand, the depth, the penetration depth of all these three are also higher than that of the high frequency 500 and 1000. For example, the Sound Aero LF300 can penetrate up to 8 meters, 150 can penetrate up to 15 meters, 100 can penetrate up to 20 meters from the surface, and from the drone it will be a little more lesser value. And all in all, these are the basic properties that you should consider before selecting your GPS sensor for the requirement. And there are also many other factors which I'll be sharing on the handout, so you can have a deeper look at the consideration you have to make before choosing the right sensor. So now I'll be dropping in the document in the handout section so you can go through the considerations and all the factors that affects the selection of the sensor. Now, yes. The data processing and the output of the sensor. I'll not be going into a deeper aspects of the data processing. It's a completely whole topic for another webinar. But usually the output data can be of these four types. a vertical slice profile, a horizontal slice, or a thickness grid in order to determine the thickness of the ice or the sand layer that's covering the surface, or a 3D reconstruction. Although 3D reconstruction requires much complex post data processing, and the GPR data from the sensor can be processed in any of the radar systems data processing software. Usually, the Geolite or Prism 2 softwares are used. Now, coming to the important point. When you have a traditional land-based GPS solution, why an airborne GPS solution is required? The answer is simple. It can travel to any location that a person cannot travel so easily. To hilly areas, rough terrains, areas with health risk or potential hazard, or for carrying out scanning or detection of a large area, the drone can do it in shorter period of time rather than traditional methods. So all in such cases, the airborne GPS solution has upper hand over the traditional methods, whether it being a hilly area or a natural disaster stricken area, the vast area that has to be scanned, the speed at which it has to be scanned. And besides these factors, airborne GPS solutions are also cost effective. Cost effective it means that you don't need to have a large crew travel to the place, monitoring, carrying the equipment. Minimum amount of crew is required to conduct such uh, surveys using airborne GPS solutions. Yeah, the main applications of drone-based GPR. Drone-based GPR solutions can be used in all sorts of activities that a traditional GPR solution is used, such as archaeological surveys, utility mapping, geological survey, construction site inspection, road and bridge inspections, and mainly search and rescue operation. Today, we will be focusing on the search and rescue operational use of drone-based GPR and how in recent times, in real life scenarios, this solution has been proven efficient and effective in landslide-stricken areas in India, particularly two recent incidents. So these are heartbreaking incidents and very unfortunate incidents. We'll be going through these incidents, what happened, and how this solution contributed to the effective search and rescue operations in these regions. By going through these examples, we will be understanding how incorporating new technologies and new innovations into traditional methods can be effective and more productive. The first case I'll be talking about will be the Wayanad landslide. Wayanad is a hilly district in Kerala, India. So this unfortunate tragic incident took place on July 30th of 2024. Due to heavy rain, the landslide wiped out an entire village in the district, and a lot of people were victims of this landslide, and a lot of people were also trapped beneath the soil and all the debris that came with the landslide, and even people were trapped inside their homes covered with sand and so on. Since the area affected by the landslide was very huge, conducting the search and rescue with traditional system was practically ineffective. It consumed a lot of time. It would also not be much effective in going for places which was not so stable due to the landslide. The soil was not stable. The area itself was very difficult to access. So, in this case, the authorities came up with the drone-based GPS solution for identifying people who are buried underground under the soil and the debris, and to conduct evacuation and rescue in prompt time. So GPS solution. By the way, these GPS solutions were constructed by Indian departments itself, and these GPS solutions were used in these places to identify people who are trapped under their houses or under the landslides who are still alive. Uh, the radar could detect them, and the authorities could dig up that particular spot instead of digging up the whole spot, which was practically impossible, and take out the survivors. Also, it helped in identifying dead bodies which were covered in the soil, and of people who were reported missing due to landslides were later found under the soils with the help of such systems. The next case is of a landslide which took place exactly 2 weeks before of the Wayanad incident, again at India, a state called Karnataka. The landslide magnitude that hit this place was much lesser than that of Wayanad, but it swept away vehicles and roads from the path to a nearby river from a hill. And amongst the vehicles that were swept into the river, there was this particular truck driver who was trapped in his truck when the landslide occurred. And for a couple of days, it was believed that the person is alive in the truck was and the authorities were doing all the desperate measures to rescue the person. Sorry, I had to go for a little drink break. So yeah, so the authorities were desperate to find this person alive and well before anything mishap happened. And for a couple of days, they were using all the traditional methods, trying to dig up all the areas, but again, ineffective. This was a large area, and finding a truck and the driver amongst all this huge debris was a pretty difficult task for them. Traditional GPR even were used for a couple of days, which found no effectiveness. And after a few unsuccessful days of operation, the authorities brought in again drone-based GPR solutions to conduct scans of the entire area. With the help of the data that was received from the airborne GPS solution, it was confirmed that the truck and the truck driver was not trapped in the soil that covered the place, but rather the truck was swept away into the river, and then the position of the truck was also attained using the data. But unfortunately, the driver was not alive, but it allowed his family to find a closure, and the much rescuing operations were stopped, and that's it. So basically, what we understand from these two incidents are that when you take up new technologies into your current operations, it becomes more effective. Investing in such technologies can be more productive, consume less time, be more cost efficient. And that's the end of our webinar. I hope all's clear. And in case you have any doubts with the webinar today, you can either post it over here or contact us directly through our mail address. And finally, we are also conducting a live demonstration of all these speech engineering solutions for advanced mining, surveying, and other scanning, such as EPR, magnetometers, bathymetry, or all the solutions on October 30th of this year. It's a free live demo, and if you wish to attend the event, you can register it over here. I'll also drop in the brochure for the event in the handout section. All right, people. Thanks for attending the webinar. Thanks for joining. And you can find the brochure for the event in the handout section. Register for it if you are interested. And for any other clarifications or support, you can contact us directly. So have a good day all. We'll be seeing another time with another interesting webinar on another interesting topic. So bye all. Thank you.